In question 30, we've been given this series, Cn x to the power n, and it converges for when x is equal to 4, but diverges when x is equal to 6. Now, with this problem, we can't assume convergence at x equals 4, so we don't know where the convergence ends. So we don't know if, we know probably at 0, because since it will alternate, be an alternating series up to 0. But at x equals 1, we don't know if it's going to be converging or diverging. Okay, so taking a look at 1a, we want to see what's happening with just the c. So what we can do is we can do this comparison. Okay, we know that cn, and that's going to be negative 4 to the n. Okay, we know that this is convergent. Okay, we know this is convergent the way it is. So we're going to look at a case where cn is alternating. And if we make Cn alternating, we end up with a series that looks like this. From n equals 1 to infinity, or 0 to infinity. And if Cn is alternating, what we can do is we can factor out the negative 1. We can go Cn. Okay, so we're going to make that positive. And we can factor out the negative 1. Okay, that's what makes that, well, that's what will make the Cn alternating. And we're then going to pair it up with that minus 4 to the power n. Okay, so why are we going to do that? Well, we can show that it does converge absolutely for x equals positive 4. So although we can't assume convergence at x equals 4, what we're going to do here is we're going to prove that that is actually true. Okay, so let's put that up there. It should be Cn. Okay, so what this means then is we know that we have this series from n equals 0 to infinity. And we know that this series is convergent. I'm going to take this out. Okay, and we're going to say we'll put those together, and together they're going to make negative 1 times negative 1. They're going to cancel out, so we end up with 4 to the power n. And if Cn was alternating, we know that this is convergent. Okay, so we know that this is convergent. Okay, so if that's convergent, we also know that Cn is less than, we know that this is less than Cn times 4 to the power n. Okay, and we know that this is convergent absolutely. So we know that in this case, this is convergent absolutely. It's not a conditional convergence, so we know that converges absolutely. So then we can say that Cn is less than 4 to the power n. And so we also know that Cn, so n equals 0 to infinity, we know that this series must be less than this series here, which we have shown that is converging absolutely. Okay, so we know that's converging absolutely, and so we know that this must also converge, right? And not only converge, we know that this converges absolutely. Okay. So we've done the case where it is alternating, so we need to then make sure that it works when it's not alternating. Well, if it's not alternating, if we see it is not alternating, okay, so we're going to write that case down. This is case 2. Cn is not alternating, okay, that means that we've already proven that Cn converges absolutely, so we know that this Cn is convergent absolutely.